So the tree map main purpose is as just like a tree set, it needs to store the sorted data. So let's actually look into of like how my tree map. So first hash set I can store the data and read the data, and what's the advantage of tree set and storing in a tree map and reading the data from tree map. Uh, so today we'll learn. It's a student. Already we have this class. Right? What I'm going to do, I am creating student. I don't want to set grade. So okay, everything else is here. So what I'm doing, I am instantiating, note down. So yesterday I didn't do intentionally hash map equal. I did hash map equals to hash map yesterday, but it's always good practice to use the super classes when you reference actually the underlying implementation. You can give like anything, but it's always good to store uh, the appropriate implementation and give the superclass reference. So it's a student. And one more thing, actually, I noticed some of people uh, gave like a random name. In not in Java, anywhere actually, it's advisable to use. I mean, I didn't do anything here, right? See what editor gave me map. So prefix or suffix, basically suffix may be a good way. Use the appropriate data type. So you don't need to verify in your program like what data type it is, everything, right? It's more readability. It increases the readability when you give like the appropriate data type as a suffix. So student map, new hash map. So again, class name should start with uppercase. Sabha, for you, package names, generally every package name, all letters will be lowercase only. Student may have, okay, put one new student. Uh, so I'm taking 10 students. ID is 2. Zero. So I took some Greek alphabet letters for my names. So I gave marks. Okay, I added everything in a map. All students are added in a map with their respective student IDs. Okay. Now if I retrieve them, I will use for each loop. Student map is my where I'm retrieving. I'm not using iterator. You can use iterator as well. So because my values are this type, so what I'm doing, I'm iterating entry set. It give entry set. Actually, I'm iterating on entry. So it will give a map dot entry, okay, of integer and yeah. So it gives like a map dot entry of so it gives me map dot entry is my data type. Again, remember the for each loop syntax is for for each loop syntax is for data type, okay, variable name colon collection. This is my for each loop syntax. Here it is the block of code, and that followed by termination. So what it does from this collection, okay, whatever the collection here it is there, it iterates on the collection and gives you each and every element in a variable name, and that in the loop actually can use it. Here actually variable name actually can use it in this loop. So when actually this collection is completed to the end, every time actually it gives the next element. When this collection is completed, actually it exits from the loop. That's what actually for each loop. And it is added from Java 5. For each loop, I think it's added from Java 5 onwards. So anyway, it's Java 8, Java 16, 17 is also there. So we don't need to think about like in the past how it was. So now what I'm doing, I am taking this entry. I'm printing in all student details. So in order to print all student details, what I can do, I can simply, instead of implementing here all the details, like a the business, the way what I want to print, I can simply go here and implement the print method. Again, it's supported by IDE. Look here, I will go here, generate toString. I will implement toString. Okay, it's beautifully gives all the details. All right, now right here, I will just put entry dot get value. I want value only. So what entry dot get value will give? This is key here in map. The it's the map is key value. Here we are declaring the generics here. Map is all about key comma value, right? Yesterday also we discussed that one, key comma value. Here key is integer, value is student. Key what we are storing? ID. ID is integer. This comes like a 1, 2, 3, 4, 5, 6, etc. Student object is, this is object, value is student object. When you say entry set, right, you will get entry of the same thing, whatever it's stored. In yesterday, if I go here, in yesterday class, whatever we stored, everything actually will get it here, entry set. It gives like all the entries as a set. Okay. Now that's what I get. And entry dot value, right? Now actually what we have, entry key is integer, entry value is student. So entry dot get value will give me access to the student. So it gives me basically student object, but I am not doing anything here, but you will see like it is printing to string. Why? Because any object that we pass in the system.out.println or anywhere else, actually a logger or any, or for simplicity's sake, okay, let's take system.out.print. Here, if you pass any object, by default, actually it will call the toString method of that object. Okay, you can see, you can see the code also. I mean, I'm showing you code as well. See, whatever we do, right? Boolean, what it is doing, it's printing. Print nothing but actually, let's go to print method. Print, right? String dot value of. No matter whatever it do, right? It converts them into string. If you don't give, for example, if you don't give this one, you will give a toString method will be gives you like a random reference, object reference. Let's see, run this one. What you will get it first. It gives you like a random memory reference, actually, like where the object is stored. Because the toString, generally always the toString method gives like a address of the object. But here you are overriding it. If you notice, actually here you are overriding it. So you will get, this will be called whenever you call like a toString by system.out.println, and you will get this as a string. Okay. So all these details we have, right? Now, okay, again I'm repeating toString importance. ToString is just actually to do a pretty printing. In this example, I want to just print all my details properly. That's why I implemented the toString. Instead of giving the just like object reference, I want to see like what is coming, what is there in that one. So in this example, all details I got it in a sequential order, like based on their ID. But now actually I want all students, I want to sort them based on the based on their marks. So how can I do that? That's where actually what TreeMap implementation will come. So instead of hash map, let's go with that TreeMap. Right? So if you do TreeMap, right? Now what I will do, it gives you like a, it sorts everything based on the natural order again. So let's say actually if I add this element first, pi element first, what it gives me, I just change, I didn't do anything change. See, notice actually here, the advantage of using the superclass here, I just change the implementation and everything will change it. See now, all elements still coming in the sorted order. So again, if I change to the hash map, I didn't do anywhere else. So my implementation is changed. Why it's coming still in sorted order? basically here the order is not guaranteed. I'm not sure like why it is giving you all sorted order. Let me rerun it. Mhm. So let me try to run a keep another.
Here it will sort using the keys, sir.
Yeah. So let's see. Where is my 100? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Here it is. So it came like a in a wrong position, right? As you notice, the order is not guaranteed. It came in a wrong position. So maybe based on some technique actually it is using to keep it. Okay. Now if I change this to tree map, this will be sorted no matter what based on the keys, whatever it is in the sorted order. By default, actually tree map will give the sorted order based on the keys. Right? So that gives me how I can sort it all my students. So if I want to sort all the student list, all students, right? What I can do, I need to keep them in a sort. The way actually how I want, it's not integer. Maybe I can use something else actually to sort them. So what I will do, I will this case, right? Let's take another business case, like where I want store a student and respective address as well. Okay. So let's create, this is my student data. Address I am creating. Okay. So address generally will be having string address 1, string address 2, string city, string state, string pin code. These 5 elements actually I am creating as an address. And in what my business case is now, right? So far, actually, we learned about TreeMap will give all keys in a sorted order, no matter what, how you put it. The natural order, if it is like a primitive data type, the natural sorting order will be maintained. We also learned in the tree set actually how the comparable interface will work, and how actually it can help you in storing the elements in uh, uh, the order which you want. Okay, so today actually in further extension to the tree set, actually we are implementing the tree map. So while we are implementing the tree map, what I want to do it, I want to store student as my key, address as my value, and all my students I want to store them. Yeah, all my students I want to store them uh, based on their marks. So whoever is the first marks, I want to give them ranks uh, based on uh, the total marks. Okay, let's see actually how it works. I created address, right? So I'm creating the constructor as well. See, the ID will give you another opportunity, like another example, how you can create constructor as well. I don't need to type anything. So my key is student, same thing student. Now I want new address. Okay.
Address one.
Yeah, address one, address two, city,
State.
state, pin. Okay. These are my details. Let me keep them. Okay. So let's take um UCKNOW. I don't know.
C. Yes.
Yeah. Okay. So I took like a random. I don't want to fill all the addresses for that purpose. Right? Main purpose is I want to sort them based on the way it is. So let's see like it gives. See here it is not. Here it is student. Let me see actually if everything is coming in the sorted order. Now if you look
So we
student
set
object actually.
we
What's
set
that?
student as a key here and address as a value.
Correct. Exactly. We changed our implementation. Student is my key now. Okay. Here student is my key. Address student address is value. So I just want to keep them in a sorted order based on this student marks. So let's see like what it comes. It's a tree map implementation. So let's see what it comes the output as expected, right? Oh, yeah, as expected. In tree set, actually, we saw this one, right? When we try to add a class without comparable, we are getting an error like, okay, this is not comparable. So basically what happens, right? Tree set, all keys are nothing but actually a tree set. In a tree map, all key set. So if you see hash map, all keys stored in a hash set. When it comes to tree map, all keys stored in a tree set. So basically, whatever we learn tree set, it will be useful when you are using the tree map. So what we need to do, all the student now, we need to implement the comparable interface for this one so that actually we can give like a what is the sorted order. We can ask like a why it didn't throw error when we store integer key. So the answer is if you go and find what is java.lang. not source code, API. It's implements comparable. Integer implements comparable. So that's why actually it goes to the, if you look into that one, there should be like a compare to method as well. See, compare to. It gives like a natural sorting order by comparing the two integers. So that's why actually though we didn't implement integer, the implementation is already there in Java. So we don't need to specifically give that one. One second. Uh, just one second. Okay. So, okay. Let's go ahead and implement my comparable interface here. So what I need to do here, implements comparable. So on what basis actually, if you look into this one, comparable is also a generic type. What it needs to comparable. In last example in tree set, actually, if I don't specify the generic type, right? What happens? Let's first try the generic implementation. Now what I need to do, compared to, I need to implement it. If I do it, actually it's coming like a object, and then actually I need to cast it actually object to argument student equals to student of, oh, I need to cast it, right? This one, right? So if I implement generic, that code is avoided. Here what I will do in comparable, I'll pass student. Right? So now actually I will try to implement the implement method. See, it's coming student. It's not coming like an object or an earlier case. Okay, that's where actually you will avoid casting as required. Casting whenever it is there, right? If you implement generics, actually you can avoid casting. So now what I need to do, I need to verify the marks. So whoever is getting the first marks, I want them in a sorted order. So what I will do, again, there are three possible things here. One is greater, less, or equal. Okay. They are the only possible three values here. So let's actually first, instead of I take the responsibility, it's already implemented the integer, right? So let's reuse that whatever there in the integer class. What we have, get marks, right? So what I will do, integer, I'm converting them to wrapper value of, value of my marks, okay, dot compare to, I'm just converting them to a wrapper object here, nothing else I'm doing. O dot marks, because I can't get marks dot compared to here, right? So I'm converting them into a wrapper object by using this integer dot value. There are two ways I can do it. One is I can convert using integer dot value of, or I can simply This way also I can do it. Cast it to a wrapper object. This is like just generally there is a concept called auto boxing. It downgrades any object actually. If there is a integer wrapper object, it can compare that one. So for example, actually, this is what auto boxing. Your parsing actually compared to generally takes a integer object, right? Integer. But what you are passing a integer, primitive data type. So it automatically box up to the wrapper object. That's called auto wrapping. Here we can casting it. This is also okay. So this way also we can do it. This way also we can do it. Both are right. So I'm giving them the responsibility, how the sorting order is. So let's run this one now. See, all my scores are coming in a sorted order. But this is not actually what I want, right? I want whoever comes first, I want them to be the first one. So what I will do, I will just negate this one. I'll just negate with minus mark. See, now all the marks are coming in a sorted order. So again, you can ask like, what if there is a same marks? Let's take, 67, 67. There are two marks actually where there are same. Unlike 1, 2, 3, 4, 5, 6. See here, it's considered as a duplicate, and it's not storing another 67. The first 67 cos is there, but you can't notice that it is a there is a another pi. So that's where actually you can think not only if it is same. What I will do, I don't want to miss any student, right? So what I will do, this condition will not give me the right value. So what I will do, if this dot marks equals to O dot marks, right, then return should be based on the student numbers, student names. This dot name dot compare to O dot name. So now what it give me? So far actually we didn't see pi, right? Alpha, beta, gamma, all are there, but there is no pi. So let's say actually if pi comes here now. Yes. Okay. So when you use, based on this, like what you have to learn, when you use compare to, you need to make sure that you are not missing any values. The compare to logic is giving all necessary details that you can take. You can consider like each and every object as individual, and still you can sort them. So all possible combinations you can think about and then write your logic. Okay, any questions so far?
Yes, sir. Can you
Yeah,
go
go ahead.
compare to method? We can
Yes.
calculate in that method, sir.
Sir,
Can
what's it?
I want to calculate grade. So I can calculate grade in this method compared to or not?
Date, you are saying date, calendar date.
No, grade. Marks.
Grade also you can do it, but I don't have grade so far, right? I didn't set grade for each and every person null. You
Okay,
haven't completed that assignment actually. That's why I didn't put grade here. Yeah, you can use grade. Or you can
okay.
use date also. All right. Student date of birth. Date of birth.
Yes, sir. My question is in compared to method, can I calculate?
Yeah, you can do that.
Okay.
So now actually not based on my student marks, I will do like based on the date. So let's say that just 1 second. Though it's deprecated means actually it's not being, don't use this one, but I will still use this one just for my simplicity sake. That means actually they removed that method. Uh, they're advising you that, okay, don't use this method and we are going to remove it soon. That's what deprecated meaning is. So now if I want to sort them based on their dates, like simply I can keep instead of marks. Okay. So first preference is for me, I want to sort them on dates. So I can still use this dot dob dot compare to. See, every object nowadays coming up with comparative. So we can use that leverage that one. If they are equal, then follow this one. Else return this one. If their date of birth, what it means? If they are equal, date of birth is equal, then do the next algorithm. If DOB is equal, then sort them by marks and name. If marks are same, then sort them by name. So it is like the first level of precedence is my date of birth. If date of birth is say is higher, right? Then a lower actually it will sort them, or I can give like a minus. So whoever is the highest date of birth, actually they will be printed first. Okay, I don't have date of birth here, right? Okay, some random date of birth is coming next. 3899. What I'm passing here, is it year? Year 1990. Okay, basically it's coming like a random date of birth, but you can see it's like a 3899 is what actually the highest date of birth, right? and 3880 is actually lowest, like elder one. First one is the youngest person. For some reason, that's what, like that could be the reason like why they deprecated this one. It should be maybe 0. So what date will do, right? Generally, they will. It is calculated from 1970 onwards. When yeah, so from 1990 actually it calculates the date. So that's why actually it is everything is summing up. We'll learn about the date concept maybe in next class or coming classes. But you got it right, like how we can sort based on the data as well. This is the eldest one, this is the youngest one. If you want in reverse order, remove this minus sign, so we will get it in the reverse order. Okay. Yeah, any questions, Sabha? Any questions from others?
No, sir.
Yeah.
No, sir.
Okay, then we'll stop here. I still request to complete your assignment. I will leave. If you want, actually, you can stay. Srujana, you can share your screen, and Sabha and other will connect. If you still have any issues, right, send me email. I will take a look.
Okay, sir.
Okay. So it's all yours. I am leaving. I'm making Sabha as host.